Hello, welcome to this demonstration of the Costing Nature Ecosystem Service Assessment Tool. We're going to be running a baseline analysis and we're going to do scenarios where you change the priorities and values. We're going to be doing this today at the mega user level. So I'm signed in as a mega user in Costing Nature. So you can see here that I'm signed as a mega user. So the first thing to do is to set up or define our area of analysis. So in this case, I'm going to be running the system for the tile that we are currently focusing on. So we can run this at two resolutions. We can run this at 1 hectare resolution, which is these purple 1 degree or 100 by 100 kilometer tiles, or we can run it at the larger blue tiles, which are 10 degrees by 10 degrees, so roughly 1,000 by 1,000 kilometers. If we run the blue tiles, we run the system at 1 kilometer resolution, and if we run it at the purple pink tiles, it will run the system at 1 hectare resolution. So we need to give this run a name. Ecuador. Leave this at 1 kilometer because we're going to be running it for the blue tile, and we're going to go to step 1, define area. And now you will see at the top here our run name has changed to Ecuador. Now the next step then to set up a run is to prepare our data. So I'm going to the left here and click on prepare data. And I'm going to copy over the data for the full extent of the tile. So I'm going to click on copy data directly to the workspace. So what the system is now doing is copying over data from the SimTerra data server into your own workspace on the server. That takes a few minutes maximum. So now our data is ready, and so we can have a look at the data that is in our workspace by clicking on the plus minus. And what we see here is a whole list of all the data that is needed by Costing Nature to do a run. Some of this data we can have a look at, the ones where it says download and where we have the view data icon. Other data we can only look at by aggregating over other maps. So for instance, we can look at the change in precipitation for the future by clicking on the view by, and that allows us to, for instance, summarize this subbasins. So see at what is the mean precipitation change to the 2050s by subbasin. And so we can do this for all the maps that are listed here. You can aggregate it over those maps just to get an idea of the data. But other maps you are allowed to have a look at, such as the tree herb cover. I'm going to close this window now because we are ready to set the simulation running. So I'm going to click on step 3, start simulation. And here we have the option to index globally or index locally. By default, it's set to index the maps globally, which means that all the output maps will be scaled between 0 and 1 on a global scale, which obviously means that it will be easy or you'll be able to compare areas that you run. the simulation for. But you can also opt to index locally, in which case all the values will be scaled to 0 and 1 for your tile of analysis, or if you have masked it for your area of analysis. I'm going to leave this now for to set to index globally, so I'll leave it to the default and click on Start. And this will set my baseline simulation running. This shouldn't take more than a few minutes. Okay, so the simulation has now finished. Close this, and we can have a look at the outputs by going to step 5, results maps. So we're skipping step 4, which is the policy exercises or the scenarios, and go straight to looking at the results. Now, this will give you a list of all the output maps. Because we're using the mega user level, we get to have a look at the individual services. So, for instance, we can have a look at the total relative realized water provisioning services. So that is the relative volume of clean, not human impacted water available to downstream people, dams. And we can look at that by clicking on Display GeoBrowse Map. And this shows us a map of water provisioning services, and that is scaled 0 to 1. So we have high values here on the Andes coast and low values here in the Amazon. Let's have a look at some of the other maps. So let's have a look at the carbon services, for instance. So this is the carbon sequestration services, living plant biomass and soil, where all the potential is realized. And you can see that because this is scaled globally, we have very high values of carbon sequestration in this area of analysis. So if we look at these in a combined way, look at the relative total realized bundled services, so that combines the services of water, carbon, nature-based tourism and hazard mitigation. And we can do that by looking at the realized services, so these are the services that are produced and consumed, or we can look at the potential bundled services. So let's have a look at the realized services. And I can pop out this map, and then I can compare this with the potential services, so the relative total potential bundled services index. Pop out this map as well, close this, and put them next to each other. So what we have here is realized services, so these services are produced and consumed, so high where people are, and these are potential services, and we can see that we have much higher values here in the Amazon, where we obviously have high carbon sequestration values, but not many people there to use them. So this is an interesting distinction to look at, potential versus realized services. Other maps in there are the relative threat index based on accessibility, proximity to recent deforestation, projected change in population and GDP, projected climate change, current distribution of nighttime lights. We have pressures, so this is current pressure based on population, wildfire frequency, grazing intensity, agriculture intensity, etc. And we have conservation priorities, and this is a map of the overlap of following maps, so the EBAs, Global 200 ecoregions, hotspots, IBAs, and KBAs. Let's have a look at conservation priority areas. And we see that some of these, even though this is scaled globally, they sum up to 1, which means that all of these maps overlay at those particular areas. So these are high conservation priority areas, whereas other regions don't have any value at all. And then moving up, we get the aggregate maps, so we can look at the aggregate nature conservation priority index based on realized services. So this is a map that shows you where is pressured, where is threatened, where do we have high conservation priorities, but also high realized ecosystem service provision. So we can have a look at that map. And we can also then do other things with the map, and this goes for all the output maps. We can change the image underneath here. We can set minimum and maximum. We can change the color scale. We can look at positives and negatives only, although this is less useful for costing nature because all values are positive. But we can also normalize the map. We can do thresholding, so we only show a certain range of values. We can mask it by another map. We can look at statistics, or we can download this map. We can also aggregate this map using the view by function. So if I click on that, it allows me to show the values based on other maps, for instance, sub-basins. And you can see that we have very high values in the center here and very low on the coast here. So this is a whole range of viewing your output data. We can also look at it in Google Earth or Google Maps. And if we look at it in Google Maps, we can then also query individual points. This can be done by moving the map, zooming in to an area of interest, so we can, for instance, check why the values here are so much higher than here. If I click on query, I will get the value of the cell where this crosshair is centered. So the value there is 0.18. If I then click on inputs, and on the query inputs, I get the values for all the components that make up this map. So if I click on show all, we can see that the relative threat index at that point is very high, 0.44. The pressure is low, nature-based tourism is low, water provisioning services is low, but carbon is very high as expected. Biodiversity is very high, and therefore we also have a high conservation priority. So even though this is an aggregate map, by querying for a particular point, you are able to get the values of the components that make up the aggregate value at this point. So I'm going to close that now, and I'm going to move on to applying one of the scenarios. So we've done our baseline analysis. Once we've done that, we are now able to do a scenario. So by clicking on step 4 policy exercises, I can then select the kinds of scenarios that I would like to do. And so we have a couple of options here. We can change the input maps. We can do scenarios of land use and land cover change. So we can look at what are the impacts of changing land use on ecosystem services, for instance, deforestation, reforestation. But what I want to show you today is priorities and values. And this allows you to change priorities and values assigned to the elements of conservation priority. So if I choose that, we get two options here. We can do prioritization, and what that means is that we can change priorities that are associated with the different components of conservation priority. So, for instance, we can change the weight for different components on the basis of local priorities. So in the example given here, we can change the weight for carbon, for example, if you're working on red projects. So you have the different conservation priorities here. You will give it your policy a name, and then you can change the different weightings. So biodiversity, conservation priority, pressure, or threats. And you can target this as well in a specific area. For now though, I want to use the other options of changing priorities and values, which is the valuation. So this allows you to change the values with which different ecosystem services are held. So we have the 4 services in the system. So carbon, water, hazard mitigation, and tourism. And we can change the weighting between 0 and 1 for all of our services. So as I said in the example here, you can change the value placed on watershed services upstream of dams. So let's implement that scenario. So I want to increase the weight that I give to water ecosystem services, and I want to decrease the weights of others. So I'm going to set these to 0.5, for instance. Hazard mitigation 0.5, tourism to 0.5. Just going to call this scenario. And I want to target this in watersheds of dams. So I click on watersheds of dams. And we have a number of large dams, watersheds in there. And so to target it for all of them, I can just set greater than 0. So this will apply the scenario for all the areas where we have dams. So all the other areas will remain the same, the weighting will remain the same. But for my watersheds of dams, I increase the weight I give to water ecosystem services. Close that. I can also implement other rules, so I can ignore certain areas within that, but I'm not going to do that now. I'm just going to click check and submit, and that should set up my scenario. So my scenario is now finished building, so we can have a look at it by clicking on show baseline and scenario. That will generate a comparison between the baseline and the scenarios. And that shows me then the weights for the different services. So if I click on weight for carbon, you can see that on the left we have the baseline where it was weighted as 1, and on the right we see the alternative weight for carbon for those targeted areas of the dams. And similarly, if we look at the other services, and obviously because of the changes, we now have a much higher weight for those areas where we targeted our weight for water than in surrounding areas. So this is what we expected to happen. So we can close this window and we can set this scenario running. And that will straight away start running the scenario. It should take a few minutes. So that has finished running, and we can just click on view all results, or we can go to step 5 results. All results should show me changes. So now we have our output maps here, but instead of the green icon we see a change from baseline icon. So, for instance, let's have a look at the water provisioning services. Compare. And that shows us that we now have a increase in water provisioning services because of the higher weighting in those areas that we targeted. So this is the change map. Click on the plus marks here. We see the baseline on the left. We see the alternative on the right. If I hover over here, you can see the changes in the mean for the whole map as well. And if I move all the way to the bottom, you can see the percentage change as well from baseline. So we have 60% change in water provisioning services for those areas where we targeted our scenario. So if we have a look at the change in relative aggregate development priority index for the realized services, we can see that we have changes in those areas that we highlight as well. We have higher relative total development priority index based on the realized services. So that concludes the running a baseline in cost in nature for the mega user level interface and changing priorities and values demonstration. I hope that was useful. Please have a look at policysupport.org and have a look at the trainings that we do as well, web-based or physical trainings in London, if you want to know more, or contact us on the email addresses listed here. Thank you very much.